So good morning, everyone, and thank you for joining this webinar. So as you can see on the screen, this webinar topic is about driving innovation with cloud data and AI platforms. This is being organized in partnership with TIE Sydney and Big Insights. So we have some eminent speakers with us, starting with Raj Dalal, David Triggs, Vinay Samuel, and myself, Chris. A quick intro to all the three speakers, starting with Raj Dalal. Raj Dalal is a Chief Data Officer, Big Insights. Raj is a trusted go-to authority for organizations wanting to drive data-led business innovation. He crafts digital strategies focused on stakeholder value using data and AI technologies and techniques for his clients. He started Big Insights in 2013 with a focus on big data analytics industry, research and advisory. At Gartner, he worked with chief data officers on roadmap balancing, need for data-led innovation and governance. And the quick introduction to David. So David Triggs is a consulting data scientist and CTO. David advises on data science capability, development, and effective deployment of smart solutions that use advanced analytics, machine learning, and AI-enabled digital transformation. Previously, he has been principal consultant, analytics with Hitachi Consulting, CTO of Big Data Analytics Research and Consulting Startup, and senior IT strategy consultant and a principal solution architect at HP. The third speaker we have with us is Vinay Samuel. He's a founder and CEO of Zetaris. So Vinay is a veteran in the data warehousing analytics space over the last 20 years. He has worked with data leaders such as Teradata, Netezza, Greenplum, Vertica, which led him to start Zetaris 7 years ago to create technologies that reduce time to insight from dispersed data in the enterprise. Customers use Zetaris to create a single view of all of their enterprise data in the cloud or within the company instantly through a simple point and click data layer software interface within a governance framework. So that's the introduction of three speakers. Myself, I'm a founder, CEO for Insights, which is a data research analytics company. So with that, I hand over to Raj. But before that, quick housekeeping instructions. Request everyone to mute themselves and also have your questions sent via chat. And we will have the questions and Q&A session towards the last 15 minutes of this webinar session. And with that, I hand over the presentation to Raj Dalal. Raj, over to you.
Thank you, Chris. Thanks for helping us moderate. I want to welcome on behalf of TIE to the launch of the Data and AI Special Interest Group, as well as, we'll be doing this on a monthly basis with a view to helping you keep on top of the fast-moving space in data and AI. So welcome everyone again, and thanks, Chris. Chris, would you mind if anyone enters just to admit them into the webinar? I'll just just focus on the presentation. So really, what I want to do today is just to give you an update in terms of where we're at with driving innovation, specifically focused in the cloud. And given the situation we're in, we're already seeing some early winners and I guess some losers as well from a business point of view in the COVID days. So it's ironic that it was a Chinese philosopher that says maybe we live in interesting times. And given the situation now where we've got billions of people who are locked up, and it's changing the way we work, live, and play, it's really making a profound impact on how business is being conducted, as well as how it's likely to be conducted in the future. And that's accelerating a lot of digital innovation. So what I want to just kick off and say, why this is even more important than it was, pre-COVID, and then help translate that into, what are the things you can start doing. And David Triggs and Vinay will talk a little bit about some of the how and where as well. So I guess, being an advocate for being data driven, the first thing I'd like to do is, I guess, share my perspective in terms of, well, why is this important? And what are we seeing? So, as I said, there's billions of people who are now working, living, and playing, from home or not far from home, and it's really accelerated the adoption of digital channels. This is, one survey that was done in the US by McKinsey in terms of the COVID bump, as I like to call it. Even in mature industries like banking, what you have by the time early April, we've got an extra 20% who've adopted digital banking, entertainment, an extra 20%, apparel, utilities, and even, industries like insurance, which tend to be behind, have got, a massive bump in terms of online adoption in the whole process. So, and as various CEOs have said, various executives have said, we've seen many years of digital transformation and adoption happening in a period of months. And as they say, necessity is the mother of all invention or innovation, and we've definitely seen that in the digital space. And you've got to think about, is this the new normal? Even post-COVID, whenever that is, will we just see continued high adoption moving forward? And in terms of winners, it's clear that the companies that have been who have been investing in digital and data technologies are now the clear winners. So I've got this graphic, and you've probably heard about the FANG index. This is the FANG Plus index, which actually groups together Facebook, Amazon, Apple, Netflix, Alphabet / Google, Alibaba, Nvidia, Tesla, Baidu, and Twitter. Each and every one of these companies are the absolute leaders in their own little way in data, AI, and cloud at scale. And if you just look at their financial performance in the 6 months to date, we see that after COVID was announced, I guess COVID became mainstream, and it was everyone was taking it seriously. We saw a massive drop in the share price, but it's accelerated and really outperformed the market. And this is compared to the S&P index of increasing about 6% year to date. So we already have winners and losers. Well, these are certainly the winners, and some of the old world industries are really suffering in this new normal. So what are some of the other data points on why we should be focusing even more on digital and data mastery? This is a quick analysis from Deloitte looking at how digital mature companies perform against lower maturity companies. And they found some clear correlation between higher revenue growth, profit margin against companies that were less advanced in the digital maturity space. And we break that down even more, down to what are the initiatives that actually pay off. And it's a complicated slide here, but we can see that if you break down the whole digital journey into data mastery and automation, they actually end up being the ones with the highest, effect onto all the business drivers like cost efficiency, revenue growth, product and service quality, customer service satisfaction. And what do I mean by data mastery? It's about embedding the data-driven insights into the tools that employees use every day. It's about making sure there's self-service portals available so that employees with different levels of seniority can go through and get the information required to make decisions. Especially in this time of rapid change. And then in terms of product and services, packaging those insights into superior customer service and packaging that into customer journey. And intelligent workflows is really taking a lot of that insights and producing that into algorithms and workflows for automation. So in terms of where we're focusing on in terms of data insights, I just want to summarize, I guess, where we're at. We started off with numerical text analysis and just producing simple dashboards and reporting, and that's very important at the moment. Even more important, people used to look at this, reports, dashboards, perhaps every few weeks or months. Now, in the rapidly changing environment, they're doing it daily, if not hourly, using more of the data, speech, image analytics, using machine learning, predicting the future. What has become mainstream at the moment is become, chatbots using natural text language processing built upon, data from within the enterprise. And the nirvana that everyone's chasing and is working towards is how do you bring all that intelligence and mix it in with automation to replicate and automate, repetitive tasks. One of the startups I'm working with at the moment in the insurance space, they've come up with an automation for claims processing, where for low value claims, what they can do is they can look at the past history of claims and quickly triage the ones that require human intervention, but 80-90% of them they're approving automatically, and that's a very clever use of technology. Some other areas where we're seeing the innovation in industry driven by deep use of data and AI is in this area, industry specific applications. So a few years ago, I started an initiative called Data and AI Innovation Awards, and we really saw the application of these technologies advance over the years. So the number one area that most companies are investing and doubling down in data and AI is in this blue layer, which is the whole acquiring, growing, and retaining customers. And if you look at where the B2C companies have done really well, they've done an outstanding job of customer journey mapping, as well as improving the experience over there. Same thing, optimizing the supply chain. As more and more companies are moving away from a single supply in one country, they're rejigging the supply chain to have multiple countries where you get the goods from. You look at where opportunities for even fraud reduction. I mean, with a very timely example with the government spending hundreds of billions of dollars on assisting the economy, there's certainly areas where if they want to, they can figure out where there's some compliance and fraud issues. And that's using, sophisticated AI. So anyway, you're only limited by your imagination, and really what you require to make it happen is a very rich, data and innovation platform. And, as I showed in my previous graphic, it's the companies that are, the cloud-enabled companies born in the cloud. They're the ones, who've mastered this art. And the advantage for most enterprises now is that you can use the same tools that, Google, Amazon have used, and even, IBM have used to actually build your own platforms. And what most of the, cloud vendors are providing at a very, low cost is a stack that you can do all the innovation in one place. So obviously, to store the data, to ingest data at scale, to even do analytics in the cloud. And if you're born in the cloud, you can go all in the cloud. But if you're a mid-sized to large-sized enterprise, going 100% in the cloud could be a multi-year journey. So it's certainly going to be a dual hybrid approach, and really what we're finding is that a lot of the innovation or proving the business model in the cloud and doing the machine learning in the cloud is where companies are starting off, and then once they've actually implemented or found the algorithms, they may be able to execute it on-prem. But one very interesting thing that most of the cloud providers offer is reduce the expertise to develop ML applications. So the APIs around vision, chatbots, natural language processing, speech analytics, you don't need to be an expert. You just, generally just need to use the APIs provided by the cloud providers. And then, with Python or whatever, toolkit programming language you're used to, you can develop very functionally rich applications. So I won't go into the details, but this is, to do this at scale is easier said than done. What we're finding that organizations need to build what I call an innovation platform, which is really a hybrid structure for most organizations. Because the reality is that you've got multiple use cases like enterprise reporting, self-service BI, the innovation that you want to do and package that up into data services. But the data is spread all across the organizations, on-prem in ERP, in public clouds, in SaaS services, as well as perhaps even supply chain, in private cloud. But to orchestrate it so that you don't have to build another data warehouse, do more controls, you need some sort of a logical data access layer that works in conjunctions with your data governance, data security and privacy, interfaces with metadata catalogs, and can manage the data lineage. And this is not really one product. It can be a multitude of products that are well integrated, and this is a platform that we're recommending that enterprises build, to take them through this journey. So, to talk, more about this, we've got David Triggs and Vinay who'll be talking a little bit more about this. But this is really an architecture that we see, companies adopting to drive innovation at scale. So, with that, what I'd like to do is hand over to David, and David will talk us through a little bit about some details of innovating architecture. So, David, I'm just going to pass on the controls to you. Just give me 1 second. And if you've got any questions, please just do put them in the chat, and we'll get a chance to answer them towards the end. Okay, David, it's all yours.
Okay, thank you, Raj. So I want to pick up from where Raj was talking and look a little bit at some of the new things, particularly around data science, that are required to support effective innovation in the way that Raj was discussing. And have I got control of that yet? Could you just go to the next slide, please, Raj? Thank you. So I think in looking at how we use data inside an organization and the sort of data architectures that we need, there are really two areas that I think are important, and one of which is building on perhaps the more traditional business intelligence and data warehousing architectures, and there's a couple of things I just like to pick out that I think are relevant here. One of which everyone has their own definitions of what analytics are, but I'm going to focus on it in both a broader and narrower aspect. Broad in that I think it can be anything to do with looking at patterns in data, finding patterns, but also in a way analytics and BI are a little bit more narrow than data science, in that they tend to focus on providing information to support decisions. And some of data science is actually built more directly into products than that. And the other thing I just want to pick up here is that when you look at data use across these innovative digital businesses, one of the things, for example, Gartner picked out is that they literally have what Gartner referred to as huge mounds of data. And this means that there's not just a few analyses that need to go on, but people need to look at a lot of different questions. And that poses challenges for the sort of architectures that you use. Next slide, please. So the sort of architecture that you've traditionally seen has involved some sort of ETL and bringing this information together in a data warehouse. And this sort of architecture, at least logically, is still important. It's probably a little bit different today in that some of the information might be coming, say, from an on-premises ERP system. Some might be coming from a cloud-based CRM like Salesforce. And the data warehouse might be in potentially a different cloud. It might be something like Snowflake on AWS. But some of the key reasons that we bring this data together is the same. A lot of organizations need to construct a single version of the truth. And that's traditionally been done building a consistent data model using, say, star schema. And that, once it's built and operational, unlike other types of data models, is able to support quite large number of users making simple queries. So it supports a very large number of users. Some of the other things that we'll see are really tuned more to a smaller number of specialists. But having said that, it does actually take time to establish these consistent data models and to keep the data up to date. And there's increasing resistance to having to make decisions based on last week's or even yesterday's data. And so one of the evolutions that's happened in the last few years is a shift to making business intelligence much more self-service with things like Tableau and other tools like Power BI that expose tables in the data warehouse directly to these BI tools. And so one of the implications of that is that potentially business managers are expecting even more data in that data warehouse. And so there's a number of challenges around that. Next slide. Thank you. Now, you may think that data architecture is no more than the data model that's in that data warehouse, but in fact, current thinking in data architecture much more sees data architecture as the information flows in an organization, which is very much a dynamic thing rather than a static thing. And it's also a higher level thing. So in fact, always the higher levels of data models were something that even quite senior business managers could be involved in. Conceptual models involve concepts that they're familiar with, like customers, products. Even logical data models involve concepts like orders that they're familiar with. But what we're seeing now is as data and its use in organizations become more important, it's more important for business managers to actually understand a little bit more of how the data architecture in their organization works, if only to provide better data governance. that as we're exposing tables in self-service to a wider range of managers, they're also starting to have to get more familiar with even the lower levels. And that's one of the shifts that's gone on in this area in the last few years. Next slide, please. So one of the architectures that's now been around for a few years is something that has been called a big data architecture or a data lake architecture. And I think at one time there was a line of thinking that data lakes would completely replace everything else, and I don't want to push that line. But I think data lakes are interesting to think about because they're a different kind of information resource, and you will find something like this, I think, in almost any modern data organization. In particular, they tend to be the sort of environment where you can bring data in without a lot of pre-planning on exactly what its schema looks like, what the data looks like. And you can explore data that you're not used to looking at, that's new data or infrequently used data. Maybe only supporting a smaller number of analysts, but you can do things very quickly as opposed to waiting for data to be added to a big data warehouse. Now, there's one challenge you do find here, though, is that just as people in looking at a data warehouse with BI tools want access to all of the data, the same thing applies to people working in a data lake, potentially, say, doing machine learning or AI applications. And so you have this issue where you need to bring data back from the data warehouse into the data lake, or sometimes you might actually find that these two are in some sort of a hybrid. So for example, if you look at Snowflake, they actually have data lake capability within the product to some extent. If you, although in fact you still there tend to need to bring your data out of the data warehouse to actually train models on it. And I'll explain this in a minute. At the other extreme, you've got data lakes like Databricks that can actually be your whole data warehouse. But I would argue that even if you don't have a substantial data lake, you may actually have a small one because your data analyst can spin up Databricks in an afternoon for very little cost to work on a specific problem. Or if you don't have a data lake, you may actually just have some data puddles, which are like very small data lakes. Next slide, please. And just to give you a little bit of an idea, if you're not familiar with machine learning, if I'm thinking about making some sort of a machine learning prediction, typically the first part of the process is not all that different to most data analysis, gathering data, exploring it, data engineering. But the middle part uses a lot of your historical data. So if I'm looking at, say, predicting as an ISP or a telco, an offer to a customer that might call into my call center, what I typically do is I will show a training algorithm a whole lot of history of data of customers in the past and what offers they've been open to accepting, and build a model that will then help me predict what offers I should offer in the future. And so this requires actually access to not a small amount of information you might have on a dashboard, but very large amounts of information that would have to be pulled out of, say, a data warehouse every time a model is run. And also then you have the added complexity that these tend not to be used just in the production of a report, but they tend to be actually embedded in something. So if I'm looking at what offer I should make to a telephone subscriber, I need that built into my call center system so a call center agent can see that. And then over time, I need to model that, to monitor that model. So if, for example, this model was trained pre-COVID, there have been significant changes in people's usage patterns with their ISPs, with their mobile telcos. And I need to realize that my model is drifting, that it's not accurately predicting perhaps, and retrain it. So there's a whole lot of machine learning operations that needs to go on around that. Next slide, please. And one of the challenges in doing this is that the tools that data scientists use tend to be rather different to the tools that a lot of other people in IT use. They tend to work in notebooks, in Python, and these are very difficult to throw over the fence to an engineer to implement. And this can cause a lot of problems. Next slide, please. And just as one example of the sorts of challenges that can happen, this one comes from a US clothing retailer. An operations group, when faced with something like this, and this was quite common 4 or 5 years ago, would actually recode the model into something like Java for deployment, because they say all the rest of our systems are Java. And the problem is that it's very difficult then in a lot of cases for the data scientists to accurately model what was going on. And in fact, what Gap found was that they'd had a model that wasn't working properly in production, predicting sizes of things they needed to stock for about 3.5 years, simply because there was a mistake made in transferring the algorithm to production. So you actually need to create an environment that not only has the data going into the right places, but also supports these kinds of machine learning operations. Next slide, please. And so you wind up with an architecture that looks more like this. So it still has perhaps the traditional BI component, but it also has integration to, we'll call it a data lake, an area where a lot of the machine learning can go on, where the data scientist can work, data engineers can prepare the data and transform it in the right way. Some of that transformed data may need to go back to a data warehouse. Machine learning operations can go on. And then the output of some of these processes might need to go back either into a data warehouse or even into an operational system if, for example, we're pushing offers back into a CRM system. And this might not need to happen just for one model, but it may need to happen for many, many models. And so we need to think about in an organization how we're going to support all these competing requirements for data integration. And I think one of the things I've tried to show is how it is getting increasingly complex. And unless you figure out how to do it right, it can easily be a barrier to realizing value from a lot of these applications, particularly as we move into a future where streaming analytics is applied to data in flight in real time. And so with that, I'll hand over to Vinay to talk a little bit more about how you might actually implement that.
Great, thanks, Dave. Raj, are you going to put up my slide now? Yeah. So what I'm going to do is just try and tie a few of the themes together today. The underlying theme has been accelerating time to value, right? How do you keep up with the direction of innovation in the cloud, data and AI space? And so, you know, we saw Raj talk about the evolution of different architectures that we've seen over time and the various industry trends that are happening. Importantly, Raj said that a virtual data warehouse is absolutely part of the armory organizations will need to get into the new AI space. And David showed us the current state of the art. The current state of the art really for me, being someone who runs a analytical data virtualization company, the current state of the art involves moving data, involves very complex processes, recoding data, and all of that equals problems with data quality, problems with data governance, and ultimately slows down innovation in organizations. So today, what I'll lead to is what is this new architecture that people are loosely calling a virtual data warehouse, potentially virtual data lake, it ultimately addresses speed of innovation in organizations. But first, what I want to do, can we go to the next slide, please, Raj? Thanks. First, what I want to do is really reflect upon AI and what's coming, what we're seeing in the industry and across the world and in our lives. And then from there, what I want to talk about is how, you know, the trends in AI, what are the demands it has on data management and organizing businesses to take advantage of it. So, you know, for me, I have a very optimistic view of AI. I strongly believe AI is that thing that's going to give us a lot of time back, time for the important things, whether you're considering your personal life, your business life, or even your social life. I believe AI has that opportunity to help humans focus on the important aspects of life and business. Things like, you know, wouldn't it be great to have your tax done? In fact, there are many AI startups working on financial outcomes in terms of doing your tax, in terms of finding errors in credit card statements, and in terms of advising you of what products you should engage with and what services you should take up. Just, you know, yesterday I watched my wife spend a couple of hours doing online shopping, both for clothes and for food. And I really reflected on a future where, you know, an AI agent would understand what we want as a family and would actually give us back that 2 hours together, whilst the AI agent goes out and finds the food, knows what's in our fridge, understands our dietary habits and the new things that we want to buy and do. And so for me, I have a very optimistic outlook in AI. Can we go to the next slide, Raj? Thank you. And you know, just in the quick research I did, the 5, I think, big areas that AI are going to have massive impacts in, and is already having huge impacts. You know, we worry about jobs in AI. We worry about, just as we did when, you know, the personal computer came out, people were worried that that was the end of, you know, our careers, and computers are going to take over the world, and the paperless office is going to stop us from doing things. You know, the same worries we have today. The current research and what organizations are finding is that AI will actually create a lot more jobs than jobs that disappear. In government, AI is going to drastically change the way we interact with government, the way we are given services, and also things like probity and monitoring within government. I'm already seeing lots of effort in just using AI to organize data, and we're involved in a number of projects in terms of data linkage. Things like, even in the arts, you know, an area that one would think is, you know, going to be slow to move, but I'm seeing a lot of projects in the arts, particularly to do with using technology as a medium for creating new things. But healthcare is one that's close to my heart. We work with the Murdoch Children's Research Institute, and we can see a lot of the innovation that's happening across the healthcare space, and just about every aspect of healthcare will be changing dramatically. You know, everything from monitoring our behaviors, the things we eat, just to help us keep well, to just doctors being able to make better decisions because the data is being prepared by an AI agent, and it's been made into a high quality and served at the right moment where the doctor needs to make a decision. All of these things, you know, if you reflect on your tax being done by an AI agent, or all those mundane things, I should say, shopping, or whether in health research, you know, data being brought together from different domains, all of these things mean 2 things. What it means is, as AI matures, towards what I call horizontal AI, meaning AI that's aware of different domains at the same time, of different aspects. As these things mature, the speed and accuracy of the underlying data platform, and also the ability to have instant understanding and meaning across many different things, is essential. And in fact, you know, we looked at the complexity of the current state of the art that David talked about, and how David said it definitely needs some sort of disruption in the integration piece. And we put forward that the disruption is virtualization. Analytical virtualization is all about being able to access data in different places in real time at the edge, not just in a central database, and being able to process deep algorithms, being able to update those learning algorithms, and being able to do real-time training of models. So the world of data management is definitely has to change, because it's just too complex and slow. The current data pipelining, the ETL approach that we've had for about 30, 40 years it's got to go and give way to a new way of thinking. So the current state, I think of, the way I describe the current state is that we believe we have to move data from source systems or across the business to understand it. Can you go to the next slide, Raj? And actually our big idea at Zetaris is don't move the data, bring the algorithms, bring the compute to the data. For all of the reasons that I talked about earlier, and what Raj and Dave talked about, for us to take AI to that next level where AI gets rid of the mundane aspects of our lives, we absolutely need to be able to understand data at the moment it's created, not at the moment it arrives in the data center, not even at the moment where it arrives in our cloud. And so what is the modern architecture for data management and analytics looks like? We believe it's a connect architecture. It's about connecting to data. It's about sending the compute or the algorithm to where the data lives, and just integrating data in real time. Now, I don't mean, I'm not talking simplistic here. I don't mean this is a very easy thing to do, because what happens if you're doing a real-time join of data, what you need to do is to still handle all the governance rules. You still need to understand the data quality issues, and you still need to apply the business logic and constraint rules that gives the data high integrity and the user trust in the data to use it. So for us, the emerging architecture is this idea of analytical data virtualization, which we call a data fabric, the Zetaris data fabric. Wanted to give you a bit more on what that architecture looks like, Raj, just the next slide. So in order to be able to speed up data integration, speed up provisioning of data, not just for AI agents, but you know, one of the big use cases we're seeing at the moment is speeding up data in legacy systems and enterprises to the cloud. So being able to very quickly migrate old systems to the cloud without having even weeks or months to do that. The architecture to do that involves the ability to connect across your data landscape. So a very rich set of what we call hybrid connectors. And then on top of that, before you actually bring a view of that data into the virtualization system, whether it's a virtual data warehouse, as Raj puts it, before you do that, you need to apply governance rules, security rules, be able to handle encryption and things like that. Then the next aspect of this architecture is what we call the semantic layer, where, you know, data in different places needs to be harmonized. It needs to be, you know, it needs to turn into a common language. The meaning of things or entities of data across the data landscape needs to be coordinated so that the business users and the AI knows what it's doing, and it's not joining the wrong things together. Ultimately, what the new architecture is about is applying this idea of hybrid virtualization, where you're virtualizing or bringing the compute to the appropriate data where it is, but also still physicalizing aspects of your data environment to cope with issues to do with you know, upstream system performance and things like that. So ultimately, our architecture that we propose is all about creating a consumption layer up to the BI tools, the AI applications, a consumption layer where the data in the back end is harmonized, it's coordinated, it's governed, security rules are applied. We also apply what's called policy-based governance on top of the data layer. And what policy-based governance is all about is really saying at query time, we want to know what that query is going to do, because we understand just security access and just putting rules in place for the analyst and the data scientist won't stop that query from being written. So at the consumption layer, there's some sophisticated processing and algorithms that actually look at what is this query going to do? Is it going to breach a regulatory issue or a business policy? Is this a potential data breach? So in summary, the way we look at things at Zetaris is that AI, as it matures, has to have access to meaningful data or pre-processed data at the time or the near real time that it's created. And the current state of the art in organizations, this data pipelining approach, this very slow, let's move data along the business to get a deeper level of understanding, is just not sustainable. And data virtualization is one of the solutions towards that. Next slide, Raj. So, that's my presentation today. I thought I'd just, give a bit of a shout out to some of the resources we have. Firstly, because of this webinar and the great work Raj has done, and to reward everyone for their time, we're giving a free access to our system to anyone who's attended this webinar. So please write down that promo code. You can go to our free trial link. So if you go to the Zetaris.com page, you'll find the free trial link, but there it is. And what you'll get is 60 days free usage, and you'll get 10% off our charges, our monthly charges for the rest of the life of your association with Zetaris. There's also free training. So there's web-based training, and we do a certification exam at the end of that training. It's fairly simple if you understand SQL. So just a simple ANSI standard SQL. If you don't understand SQL for business people, you basically have the opportunity to learn about the space, because half the training is business. It's about the impacts of data virtualization to business. So on that note, I'll hand back to Raj. Thanks a lot, folks.
Thanks, Vinay. Actually, Chris, do you want to take over, have a look at what questions?
Yeah, certainly. There's one question for Vinay. That's what type of data format does your platform work with? Structured, semi-structured, or unstructured?
Great question. So we work with any format. We went out to resolve the whole problem. So organizations today, they're dealing with, all sorts of semi-structured, structured, and, picture data, video data. So we have a solution that enables you to connect through XML, JDBC. I can name all the different standards, even through APIs. So we connect to things like Salesforce, Sugar CRM. We have a team of people who continually look at various connector issues that our clients have, and we continually build or augment the current connector layer we have. But quite frankly, it's been a long time since we've run into anything we can't connect to and we can't handle within our system. What I failed to say is that we actually use AI to do all of this. So, this is an AI and cloud data webinar. Our technology is actually AI driven, and we use AI to resolve both the connector issues, but also the governance and data quality issues.
Oh, thanks, Vinay, for that.
Thanks, Chris.
We have one more question coming. How does the governance layer work? Does it apply filters over multiple sources based on rules, etc.?
I assume that's for me, yeah. So we have an automated governance layer. Basically, the ability to do data virtualization demands that you consume metadata, that you can have a very sophisticated way to both derive and establish business rules about the data and create constraints. So what we do is we've got a thing called a schema and governance store within our solution, where you consume schemas, you create and detect constraints and business rules. And once you've got that ordered central set of business rules, metadata, data quality rules, that's the engine, or that's the central point that our engine acts on to be able to apply data governance. The other thing we do have is we have a set of IP across 14 industries that automates the building of the business view of the data. For those of you in data modeling, this is the automation of the data modeling piece. It actually augments data modelers. It helps them do data modeling faster, but also deploy data modeling towards being able to be queryable.
Okay. Thank you, Vinay. And one question for David. Question is, David, for you. What trends do you see emerging for machine learning operations, MLOps?
Yeah, so I talked a little bit about this. So I think that the insight behind what we talk about as MLOps is that a lot of the same techniques that can be that have been applied successfully in DevOps to automating the whole process of taking software from development into production in a reliable way have a lot to contribute to the machine learning space. So this is an area that's still very much under development, but there's basically at the moment, there's two strands in it. One of which is people coming from the DevOps space, applying existing DevOps technologies and approaches to machine learning and adapting them, because the fact that you're building all these models is different from the software development process. And so the other thing you're seeing is you're starting to see some specialized things coming into MLOps, like Databricks ML Flow, that is designed to track all the experiments you've been running and the production use of your models, and to integrate that in. But it's still very much an emerging area, and I think what you'll see over time is these two strands fuse together into much more integrated solutions.
Yeah, sure. So anyone would like to ask questions, please, by all means, you can unmute and ask verbally, or even you can text in the chat box that's available. But one more question for you, Vinay, is there any healthcare data fabric use case we can refer to, especially privacy, security kind of concerns?
You're muted, Vinay.
Oh, no.
Apologies. Sorry, folks. Yeah, so I was saying, yeah, healthcare is absolutely a big space for us. We've got quite a few healthcare customers. The one that's gone public is the Murdoch Children's Research Institute, but we've got quite a few healthcare customers, and absolutely privacy, security is key, right? We take privacy and security beyond just the industry standard around applying the data privacy provisions, but also having robust security and technologies that support that notion. We take it to the point where we can apply specific rules by user, by role, also by activity, and we can govern not just that user, we can govern the query that the user is writing. We call that policy-based governance, and policy-based governance for privacy. So whilst a user might have access to, I don't know, the customer or the patient table, the billing table, and maybe some sort of index radiography file that shows radiography, whilst the user might have access to that, there may be things we don't want, or attributes within those files that we don't want anyone to ever join, because that'll be a privacy breach. Our engine actually watches every query, every algorithm to ensure the highest standard of data privacy. Okay,
there's one. I think, Vinay, you're a popular speaker here. There are a couple of questions for you again.
Yeah, the guy with the product, right?
One quick question is, what's the usual length of time for the training?
Great, that's a good question. That depends on where you're at in terms of who you are and what your background is. For business people, it'll probably take about, I would say, if you're serious about doing the SQL side of things, for a business person, it'll take about, I'd say, 4 to 6 hours, because there's a part of it where we would want you to get to a certain level of SQL. What we bet on was SQL as an interface if you wanted to code. Mind you, our system is a no-code system. It actually writes the code for you. So you could do half the training and use our system if you're a business person. But if you want the full accreditation, we do force a little bit of coding, a little bit of SQL. So what we do is we take your SQL and we turn it into other languages to talk to other systems, which is another benefit. Some of our customers just use us as a code conversion engine. But for a business person, about 4 to 6 hours. Someone who knows SQL, someone who's in the big data game already, knows about databases, it's a couple of hours. It's real quick. And by the way, if you finish the course and you do a little video, we'll send you a t-shirt as well.
Okay. Vinay, I have a couple of questions. Probably we'll close after that. And both of them are for you again. One question is, a Gartner analyst once described a complete data fabric solution as being like a unicorn. Many have imagined it, but no one has seen it. So the question is, why do you think this is so? And do you think Zetaris has actually created the unicorn?
Yeah, our investors think we have. So we absolutely a unicorn. This is $1 billion business. I don't want to make it a big, Zetaris session, but we are growing every minute, every second with new customers who want to understand this technology because it has big implications. Like every technology that I've been involved in the early days, the analyst and the customer had a level of disbelief. And rightly so, by the way. There's a lot of people making a lot of claims out there. What we do is we say to customers, give us a use case and we'll show you a use case getting done in a matter of days or weeks, right? I can think of a large telco who was a non-believer, really didn't think this thing was possible. Large telco, that's a customer now, who in the first instance said to us, you think you can get a 6-month project done in 4 weeks? That's ridiculous. We actually got it done in 2 weeks and they wanted to buy the company. So, we've got real customers. This is not, when we talk to you directly, we show you real use cases and we have references behind it. Yeah.
I think one last question, again, Vinay, this is for you. What is the licensing model for Zetaris? Example, per user, per query, or per terabyte?
Yeah, it's about $1 million a node. No, I'm kidding, right? That's someone else, right? So it's a SaaS model. Look, we have a pricing calculator on our website, but the way we meter it, we actually meter every query. So we do query per second pricing, and that's billed monthly in a SaaS. For really complex workloads, it works out around about 2 cents per query second. That cent per second comes down depending on how much you're consuming as well. To give you a sense of pricing, we've got customers paying us $5K a month, and we've got other customers paying us $50,000 a month and more. So it depends on the complexity of your workload. We absolutely tie the pricing and the cost of the system to the value, and we know that we are at least 6 times cheaper than doing it the other way.
Yeah. Okay. I think with that, we end the Q&A session. Thank you, Vinay. You have been a busy man, clearly.
Thanks a lot, Chris.
So, Raj, why don't you have the closing remarks?
Thank you. Thanks, everyone. Look, it's obviously very topical, and we chose this this session to share some innovative technology, some thoughts. Obviously, Vinay's ideas are very popular. Having worked at Gartner, it definitely unicorn was also, a lot of people talk about this. A few companies have close to delivering. It's a very confusing space, this data fabric, data virtualization, different people call it different things. So trying is, you do try it for yourself, and that's why we've got this offer Vinay's kindly made. I think we put in the chat, and I think we'll send that out to you to try this yourself. And just want to thank Ty for being involved in this. And in my role at Ty, what I'll be doing is every month bringing together some leaders in this space, whether it be venture capitalists who invest in data and AI, to other entrepreneurs, to other enterprises, chief data officers, who are driving innovation at scales in the enterprise. So, please keep in touch. So thank you again for your time, and look forward to connecting with you soon. Thanks a lot.